said, oh, one other announcement. I think there was a misunderstanding and I was being told I couldn't do this. And I'll just tell you why, and y'all gonna think it's funny too. The people that approve things thought that this class had 24 in it and my other class had 29 in it. And I kept emailing them back and saying, I don't know what y'all are looking at, but that's not true. I said, one class has 13, the other one has 19. And they kept fussing with me and telling me that I had to meet with y'all half and half because it was over 15 or over the classroom capacity. The classroom capacity in this class is 18. And I kept telling them that they were wrong. And then finally they looked at the computer and said, oh, we're looking at the section number, not the enrollment. So I was having to deal with that yesterday. So what we are going to do is I can meet with y'all one day a week, face to face. That's the rule. This is a hybrid class. If y'all look at the description of this class, it is a hybrid class. So I can meet with y'all one day a week, just like your Spanish class. So we're going to meet on Monday every week. That's what I forgot to tell you all that. We're going to meet Monday on every week. Now, you can Skype in, you can team in, or you can come to this classroom. Then on Wednesday, everybody Skypes in, or everybody teams in. Friday, I'm gonna open up the teams from home, and if anybody wants to join or go over class or homework, we're going to have homework day on Friday. Does everybody understand that? So that way I meet, so on Monday every week, we're going to meet here at AC 236. Now, if you don't want to come to class, that's fine. You can team in. Just want to make sure everybody understands that. Does everybody at home understand that? Okay. Or everybody teams understand that. Okay, here we go. 3.2, number 23, number 9. Now let me go ahead and say one more thing before I do any of the homework questions. When I go over homework questions in Math 120, I don't do what the directions say. I do everything. So that means I do every single thing on the spreadsheet, except the 5-number summary. I'm not going to do the 5-number summary for 5 numbers. So I just wanted to go ahead and tell you that. So if I do too much, well, that's what I tell students. If you do everything for each question, then by the time you get to the test, you'll be ready for the test. And good God Almighty, why in the world would they put one like this on a? That's ridiculous. All right, so I'm going to do this in a spreadsheet because there is no way I'm going to punch these in a calculator, okay? So if you want to punch these in a calculator, knock yourself out, I'm going to put it in a spreadsheet, and that way everybody can see it on the board. This I disagree with. This is not a test question. I would never put this on a test. This is ridiculous. The most that they should put on a test is 12 numbers. Because if you had numbers like this, you would do it on an Excel spreadsheet in the real world. So I'm just telling you that right now. So here we go. And I don't care what they're asking for because that's irrelevant. I'm going to do everything. First thing I'm going to do is put everything in order. So I highlight, how many they got? 50. And we're going to put it in order by hitting data and A to Z, which means descending. There we go. Good gracious alive. Now I'm going to go over here and I'm going to put mean, median, mode, range, mid-range, variance, and standard deviation. All right, now I'm going to give y'all a second to write those numbers down. I'm going to go back to the question. Well, I'm going to let y'all write them down here because that way it's in order and it'll be easier for you. So go ahead and write down 1 through 22. And the reason I want you to write them down is so you'll have this question in your notes. So, you know, if you need it for homework. So give you a second to write down 1 through 22, and then I'll move it up and we'll do 23 through 50. So I could divide it and put it in a column right here, but that would be too confusing, and I'm not going to do that to you. So go ahead and write those down. Am I on camera?
Yeah, I was taking a picture.
You taking a picture of what?
The board.
Oh. I thought you were taking a picture on how easy you can do class over the internet to show a teacher or something.
How many .76s are there?
How many what?
How many .76s are there?
I tell you what, I'll blow it up for you.
Okay.
I mean, y'all count while I do it, but how many 76s are there? She says she thinks 5.
Okay.
All right, so copy down 1 through 15, and then we'll do it in 3 sections. I think 50 is a little bit much. All right, I'm going to roll it down. All right, there's 16 through 30. And I'm trying to get 31 through there. 31 through 45. And there's the last remaining 5. Now, the good thing about the Excel spreadsheet is they're numbered. So you know that you can go below 24 and click on the 2 below 24, and that's your median. So I'm going to go ahead and highlight those before my eyes get crazy and I can't count. All right, so has everybody got everybody written down? Miss Eves, you got them written down? Okay. I'm going to go up here and I'm going to pull 24 on the above. So 24 and 24 is 48. So that means these two are going to be our mean, so a median. So I'll just mark those. Okay, so let's go ahead and do our mean first. That's the sum of all of these divided by 50. Divided by 50. And enter. Okay, so there's the mean. The median is going to be the average of those two. So I'm going to hit this one plus this one. And I got to put parentheses around it. And divided by 2. Now, I'm sorry, I'm not going to do the mode unless somebody has already seen what the mode is and tell me which one it is. I'm not going to go through and do that. Somebody tell me, does anybody know what the mode is? We'll worry about that later. Equals the highest minus the lowest mid-range is equal to the highest or the lowest plus the highest divided by 2. Okay, now we're going to do the variance. So here, read your formula, x minus x bar. So I'm going to subtract the mean from each one of these x's. Minus the mean, F4. And of course, if you're doing this by hand, oh my Lord, it's going to take you a while to do this column right here. So what I'm telling you is, with this problem, I would very, 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 very much suggest you use technology to do 50 questions, 50 numbers. Okay, I'm not telling you you have to. I'm just telling you it probably would benefit you to use technology on this. I think they want you to, but I can't, you know. And equals this, and the formula says that after we subtract, we what? We square it. And that turns them all positive. That's why you square them. And then we what? We add them up. And that is your numerator for your variance. So I'm going to take that and put that in the numerator for the variance. So equals that number divided by what? What does the formula say? Not n, but n what? I want somebody to say something.
-1.
N minus 1, what would that number be? 49. That's the variance, and then the standard deviation is the square root of the variance. So that means that number raised to the 0.5 power or 1/2 power, and that is your standard deviation. Did anybody ever find the mode? Okay.
I think it's 0.84.
Okay, I'll take that for you. I'll take your word for it. All right, so now we go back to our handy dandy question and see what they asked for. And they say standard deviation, then round to 3 decimal places. Well, we only got 2, so let me expand this a little bit. I don't know if this is going to work. There we go. 0.060, so 0.06. We got a fantastic. I am fantastic. Oh my Lord. What does this want? On the basis of the histogram, comment on the appropriate use of the empirical rule. Okay, this looks like a normal distribution, does it not? It looks symmetrical, does it not? Yes. Yes, Hubert, it does. Okay, thank you, class. So which one says it looks pretty much bell-shaped? The histogram is approximately bell-shaped. Looks like A and C, doesn't it? So the empirical rule can be used. A, I think that's what you said, A.
Yep.
And use the empirical rule to determine the percentage of candies with weights between 0.718. Okay, well, before I do that, I'm going to go back to the spreadsheet and I'm going to do the curve. So where am I going to put the curve? Wherever I can find a space. There we go. We'll just go down here. And the mean goes in the middle. And then on the right, what do we do? Add or subtract?
Add.
Add. Thank you for your interaction. I appreciate it. Makes class go by a whole lot faster when people interact. Okay, that's not right. Oh. Wait a minute. I think I did something wrong there. Equals this number plus that number, F4. Okay, that's, 0.06. Oh, I know why, because it's, let me spread it out a little bit. There. What the heck's the matter with this thing? Equals the mean equals this number plus standard deviation there. And then what do we do on the left side? Well, we add on the right side. What are we going to do on the left side? Subtract.
Subtract.
Thank you. And copy that. Now you just apply the, I don't have my whiteboard pulled up. Hold on a second. Today is just, I'm the loser. It's the Russians' fault. There we go. Now pull up my handy dandy. No, we should quit asking me that. It's not supposed to ask that when you do the mouse. Damn Russians. All right, so let me get rid of this and then bring that back in. Sorry. And I'm going to draw my curve. So somebody tell me what's normal between two standard deviations, right? Yes, Hubert. The empirical rule says that between two standard deviations is normal. My daughter used to say normal, so I still say that to this day, normal. Okay, and what's unusual? Well, between 2 and 3 standard deviations is unusual. And outside of 3 standard deviations, what is that?
Outliers.
Outliers. Unless your Michael Jordan's in your, I don't know, Tiger Woods. People that are not every day. So, now let's go back to the question. I'm trying to get there. I'm sorry, I'm having to switch back and forth. And of course, I can't see my, I wish IT would fix this. And pull up the question. What does it ask for? Between 0.718 and 958. 0.718 and 958. 0.718 and 958. And what's the percentage between those two numbers? They're normal. And what's the percentage? What's 34, 34, 13.5, and 13.5? Should be 95%. So with that being said, 95% should be your answer. We're not fantastic anymore. We're just nice work now. Oh my Lord. We got more? How many parts does this daggum question have? Determine the actual percentage of candies that weigh between 0.718 and 0.958. Well, then you would have to count up. Oh my Lord. You're going to have to actually go back to the 718 and 958. Remember that. Go back to the question. I didn't know that there was a question in there with 15,000 parts to it. 718, well, 718 is right there. And point what? 0.958, is that the number? 48 out of 50. Somebody take 48 and divide by 50 and tell me what you get. .48 divided by 50. Tell me what you get. Round to 2 decimal places, please.
0.96.
0.96 or 96%. This is ridiculous. Use the empirical rule to determine the percentage of candies more than 0.898. So pull up our handy dandy Excel spreadsheet. Does it say 0.598? Well, that's 2.5%. 2.5%. Now,
I think it said 898.
okay, that's fine. Thank you. Okay, by the empirical rule. Now, if you did not print out the empirical rule and you did not learn it when I told you to learn it, then you have no idea what I'm talking about. Somebody tell me the page number it's on. What page number was it? Anybody have it in their notes? Well, anyway, that's 13.5%. That's 2.5% right there. So 13.5% and 2.5% is 16. Did anybody get that page number? Okay. Nobody got it. I know I gave y'all the page number. And that'll be 16%. Is that the final remaining part of this marathon? Oh no. We're just going to go to Z, okay?
132 is the page with the empirical rule
Thank
on
you
it.
so much. Thank you so much. 132. And I should have, did I tell y'all that? Yes or no? I can't remember.
All I remember is you showing us which one to put down.
Okay. All right. Well, I remember saying 130. I remember saying page, but I can't remember. But it's in your book, page 132. All right. Now we got to find out how many was above 0.98. 898. Is that 898 or 896? 898? Good gracious. This is a marathon question. I didn't see why you sent it. You are kidding me.
A lot of them.
Is that the one where you compare the means and everything? All right, here we go. Let's go back to the spreadsheet. 0.898. 0.89, well, we need to, well, that's not 0.898, this is. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Is that right? So does somebody divide 8 by 50? Somebody do that for me. What do you get? I'm sorry, what? 16? Is that it? Finally? Okay. I just wasn't expecting 50. I wasn't expecting 50. That's a little bit much. You could have done this problem with 10 numbers. Okay. So this is one of those questions that, yeah, it's okay and it's asking the right questions, but it's a little bit too much for one question. I don't know, but what am I? I'm just a teacher. Okay. Is it a test question? No. Is each one of these a test question? Yes. I would not give you this question on a test and ask you to take 30 minutes to do it. But each one of these questions are good test questions. Okay? So let's get out of here and let's go move on. Oh, great. One day, Tri-County will be up with the rest of the world in technology. 2050, maybe? Yep. People start using email to get questions. Hopefully, they'll extend that. I don't know which one we just did. I think we did 3.2. Was that 23 or was it 35? That was 23, wasn't it?
Yes.
Yeah, that's what we did. well, I'm not gonna erase it because I'd like to do it with the other class, but no, I've already did it with them. No, I haven't. I'm gonna leave that one there. This one is 3.235/11. Please don't let it be 15 parts. Okay, 3 parts. I can handle 3 parts. All right. I'm going to leave that there because we might use it again. At one point, the average of regular leaded gasoline was 3.4 with the standard deviation. Okay, I want y'all to write this question down, and I want y'all to highlight this sentence. Oh, this is checked off, whatever. This is one of those questions that I don't cover, and we really don't go over as far as a test question. So I'm just going to show you how to do it. Write down that formula. I thought this was a good question, and it's not. Write down that formula right there. 1 minus 1 over k squared. And you have every right to send this question because I didn't cover it, because I'm going to be honest with you, this is never used. Everybody uses the empirical rule.
Number 11
Yeah. Yep, everybody uses the empirical rule. This is some guy that decided to do another rule beside the empirical rule, and they put him in the book. Okay? This is supposedly just like the empirical rule, but he thinks it's more accurate. All right, so 1 minus 1 over k squared times 100. K is the standard deviation. Okay, so if they ask within 2 standard deviations, you'll put a 2 there. If it asks within 3 standard deviations, you'll put a 3 there, and so on. So the first part of the question says, what percentage of gasoline stations had prices within 3 standard deviations? So that's going to be 1 minus 1 over 9. So 1 minus 1 over 9. So I'm going to get my handy dandy calculator out. Well, I thought I was going to get my calculator out. I'm not supposed to do this. This is something IT is supposed to do. Sorry about this. Sorry it's taking me so long. Today feels like a Monday. All right, so 1 divided by 9, or 1 minus 1 divided by 9, close parentheses, equals times 100. So he believes that 88.89% is between 3 standard deviations. So you hit continue, and that's what they get. Then it says, what percentage of gasoline had prices within 1.5 standard deviations? So now we do 1.5. So get your handy dandy calculator. And now I do 1 minus parentheses 1 divided by parentheses 1.5 raised to the 2nd power, close parentheses, close parentheses, enter, times 100, and that's 55.6%. So that's going to be 55.6%. And there's that. This is not a test question because I'm not going to answer this on test. So I'm just showing you how to do it to do your homework. And then you take the formula mu minus 1.5 sigma. So plug and chug. So that's going to be 3.73 minus 1.5 times 0.08. That's how you do the 1.5 standard deviations, okay? So plug that in, and I'll do it on the calculator. 3.73, and I can't move the calculator. 3.73 plus parentheses 1.5 standard deviations times 0.08, which is your right here. Let me move it again. .08 is up here in the standard deviation price per gallon is .08. Close parentheses and enter. 3.85. And if you add it, it's going to be 3.85. If you subtract it, hit second, enter. Go in and hit the subtraction symbol. I'm getting the cart before the horse, I'm sorry. 3.61. So 1.5 standard deviations, the price of the gasoline is going to be on the low side 3.61 and on the upper side 3.85. I subtracted and I added, just like you do standard deviations. And then what do they ask? Do they ask for the low side and the upper side or what? Yeah. And it says 6 parts remaining. I thought it only said 3 parts. Okay, we got that. Now it says, what is the minimum percentage of gasoline stations that had prices between $3.57 and $3.89? So you're going to set the equation equal to $3.57 and $3.89. I shouldn't even be going over this problem because we don't use it on the test, but anyway. Oh, we already figured that, 55.6. Okay? 55.6 because we figured 1.5 standard deviation. So that came from part B right here, this part right here. Fine. Okay, this is where we set equal. I'm sorry. 2 standard deviations, and you do that by taking the difference. Yeah, you take the difference. You take 373 and you subtract 389 or 357. 373 subtract 357 and divide by the standard deviation. So we're talking about 2 standard deviations. Well, we did 3 standard deviations up top. So now you got to get that percentage of 2 standard deviations, which will take you back to the original equation, unless they're going to. Okay, they just want standard deviations, 2 standard deviations. There it is. And you go back to the original equation and you get 75%. So 75% is going to fall between 2 standard deviations. This is a yucky question. Therefore, 75% of the minimum percentage will then fall between 357 and 389. We'll go over this question again, but it's not a test question. Please remember, it's not a test question. Okay, I want to try to get to one more question at least. So that's 3.2, 3.4. This is number 5. We're going to have to wait till next week because I ain't got enough time. That's 3.5. Let me go over the 1. Okay, this is number 3. Yeah, I ain't got enough time to go over this one. So let's just go ahead and leave it at 3.2 and 3.2. So we went over those and we're going to call it a day. And I'll go over those other questions and I'll go over that, whatever his name's, I'll go over another one of those Monday. Okay. So let me pull up the handy dandy. Hold on just a second. Let me stop the presentation and stop the recording and pull up the